Our second concept here, our second application in this section is average value. And let's just again think back to tail end of Calc 1, start of Calculus 2. Average value of a one variable function. So the average value of f of x on an interval a to b is, how do you compute that? You integrate f of x from a to b, you calculate out this definite integral, and then you compute, b minus a, and you divide by b minus a, where this b minus a, this is the length of the interval. So we integrate f of x on the interval from a to b, and then we divide out by the length. So what happens now, multivariable world and double integral land, the average value of function f of xy over a region R is 1 over the area of R times the double integral of f over the region R. And so there are similarities here. This should feel like the equivalent thing here. In both of them, we are integrating f over our region. In this case, it's from a to b, 1, just along that line saying here it's integrating f over the region R. And then we divide out by something. Here we divide out by the length. Now we're dividing it out by area. This feels like that's the correct generalization, the correct analog. So, okay, without further ado, let's do an example here. So find the average value of f of xy is x times cosine xy over the region R. R is x runs from 0 to pi, y runs from 0 to 1. Okay, first off, let's just draw a very quick picture here. This is a pi by 1 rectangle, and so we can tell here that the area of R, pi times 1, is pi. So when we go for AV average value, it's 1 over the area, it's 1 over the pi, times the double integral of f of xy, x cosine of xy dA. Okay, so we want to do this, we want to integrate, do this iterate integral, integrate with respect to y and then with respect to x, or vice versa. Which order do we choose? Well, if we integrate this with respect to x first, x times cosine xy, I think we have to do that integration by parts. That would definitely work, but integration by parts might take a little bit more effort than going in the opposite order. If we integrate with respect to y first, it's very easy to just, x is a constant with respect to y. It's very easy to come up with the antiderivative of cosine xy with respect to y. Okay, so here is our iterated double integral for us to compute. Okay, 1 over pi times integral x runs from 0 to pi. Antiderivative of x times cosine of xy just ends up being sine of xy. Check that for yourself. Plop in y runs from 0 to 1 dx. And this ends up as plug in y is 1 and y is 0. 1 over pi times x runs from 0 to pi. Sine of 1 times x is just sine x, minus sine of 0 is just 0. So we're just integrating sine x from 0 to pi. 1 over pi times antiderivative sine x is negative cosine x. Plug in x from 0 to pi. 1 over pi times negative cosine of pi. Cosine of pi is negative 1, so it's negative times negative 1, minus cosine of 0 is 1, and so this looks like 2 over pi. So this is an example of computing average value. Okay, so let's end this with a pre-class problem. Please find the average value of f of xy is 1 over xy over this region with this bounds. X and y are both between log of 2 and 2 times natural log of 2.